Hello students, we are going to see the next chapter in the topic of laws of motion. The part first is over, which is just a force and the definitions of force and momentum and impulse and all those things were dealt. Now here specifically we are going to deal only with the topic of friction. So here in this book it is given as chapter 7, but in general it is the fourth chapter, which is laws of motion. In that laws of motion is a part B. So friction we already know, the definitions we know. So friction was also invented by Newton when he was doing the laws of motion. He also invented friction also. So friction is basically an opposing force. Anything which is going, it opposes. So that's what friction is. Friction has lots of benefits and a lot of disadvantages also. So I'm not going to the first page. I'm just browsing over it. The origin of friction. It's a classic theory. It says every surface, when you magnify it so much in a higher end of microscope, you'll see the surface is always like this. So when one body is kept above another, maybe even as smooth as it could be, for example, carom board. If you see a carom board surface, it is very smooth. The coins are just sliding over another. Even that one, it will be like this. So the curve surface will be like this, and our upper will be like this. So it will be depression and projections will be there. So the friction takes place. As smooth as possible, it is very difficult to do. So when you are trying to move one over another, there is an opposing force will be there. Okay. So there is a difference between classical theory and modern theory. Classical theory was saying it was like this. Now modern theory, it says, so the area of apparent contact and the area of actual contact will be like this. So they say it makes a kind of a contact will be like this. It will be made like this. So only the top portion will be like this. So they say it could be just the places wherever it is just being touching will be in touch with each other. But still, when you are moving ahead, it will be interlocking and then going up. So that's the reason it will be a kind of an force will be created. These things will not come much in the examination if we will just go over it. So friction force is a self-adjusting force. That also I will I'll look and just quickly explain what is a self-adjusting force. Suppose you have a body here and you have a block. Remember, this particular object, maybe it could be a wooden object, and it could be a floor, which is tile or whatever it is there. So both of them having a surface of contact. This is called surface of contact. These both of them will have actually a standard value of friction. The standard value of friction, maybe if it is going to be equal to 0.2 newtons is there. Let us assume the standard value of friction between a tile and a wood, if they slide over each other, this is going to be the standard value of friction. Now you start applying an external force. An external force you are applying here. The external force is started from 0.001 newtons, slightly gently a force, and then slowly increase into 0.002 and 0.03, 0.001 and then 0.01. Now when you are increasing the force, what will happen to the frictional force? The frictional force will be definitely acting just on the surface. Frictional force will be there. When you are applying this 0.001 Newton force, this force of frictional force, how much it will be? It will be this much, or it will be less than this. We already know wood and tile always has the frictional force of this much. Remember, whenever you are giving this force, this frictional force will be 0.001. Opposing force will be equal to the external force. You apply 0.05 and here also 0.05 will be there. You apply a force of 0.01, this also will become 0.01. It will keep on increasing. When external force is increasing, this force will increase. And when it becomes 0.02, this also will adjust to 0.02. So it is called a self-adjusting force. When the external force is increasing, and the friction force also will be increasing till the time there will be a maximum value. It has arrived already a maximum value here. This is the maximum value. Afterwards, friction force will not be able to overcome this one anymore. So now the external force is going to be greater than this one. If it is going to be 0.03, then the body has to move from one to another, because the friction force cannot overcome this. So even if you look at a very heavy object, when you try to push, you are not able to push, because the friction force also, it is much bigger for this one, because it depends on the weight of the body. So friction force is a self-adjusting force. I am just repeating, self-adjusting force. What does self-adjusting force means? External force is increasing, friction force also will increase to a value which is already set between two objects. And beyond that, when the external force is beyond that fixed value, then the body will start moving. So that's what given in this paragraph. Friction force is self-adjusting force. That is diagrams are given here. You can just go through it. We'll move on to the next part. Limiting friction. That is given on page number 268. Limiting friction. Okay, now let's read this one. Now if we apply force, capital F is slightly increased, the block still does not begin to move. That's what I'm saying. When the external force is constantly increasing, the block does not move. This means the force P is further inclined towards the left hand side of that force, and then static friction also increases to become equal to a new value of the force. Thus applied force is increased and the force of static friction also increases. So till the time the body is at rest, this entire time the body is at rest. So we call this force of friction as static friction. External force is increasing and this is also slowly increasing. So there is a time when the frictional force, the maximum value, now look at this one, the maximum value of the static frictional force, which comes into play when a body just begins to slide over another surface of another body, is called limiting frictional force. So now we are calling about two frictional forces. One is called the static friction. When a body is at rest, the frictional force increases, external force increases, again friction force increases, external force increases, again it increases, till the time when the external force is beyond a point, then the body has to move. The maximum velocity, the maximum frictional force is called, when the external force is getting greater now, the maximum frictional force, it is called limiting friction. When the body just starts sliding, FL. Again we'll read the definition. The maximum value of the static frictional force which comes into play when the body just begins to slide over the surface of another body is called limiting friction. Now limiting friction is definitely higher. The limiting friction is FL is much greater than Fs. FL is the maximum friction which it could just apply so that the body will try to be here itself. That's what the inertia says. It doesn't to be here itself, but anyhow the external force is so greater and the body has to move. So the limiting friction is the maximum last frictional force it would have applied so that the body will not try to move. That is called limiting friction. Limiting friction has a laws. These laws are very important. Please write down this law and keep it in the notebook. So till this time, whatever you have heard, you need not write. So you start with this diagram. And then write about the static friction, and then write about the limiting friction, the definition also. And now we see what is the value here. The magnitude of the limiting friction, how much the value will be. The magnitude of the limiting maximum static friction force depends upon the nature of the surface of the contact. I already told you. Wood and tile will have its own value. The magnitude will be nature of these two surfaces. Suppose I have, instead of this one, I have a something else. I have a rubber. I try to rub it with another smooth surface of glass, maybe. Move a rubber along the glass. These two will have its own another force. It has its own maximum value will be there. Okay, so they have understood many combinations and got into a big list of frictional forces will be there for two different things. So it says the maximum limiting static friction depends upon the nature of the surfaces in contact and on the roughness. It does not depend upon the size of area of this friction or area of the surface. So suppose I have a floor, maybe a tabletop. This is a table and it has a lamination. It's a mica top, so it is mica at the top, so it's a laminated one, and I have a book with here. Okay, so book is lying here like this, and I try to push this book. The book has to go from here to there, so it goes like this. And look at this one. Book is like this. Book is a big body and book is, maybe it's a physics book. So it's a physics book and you try to push this one. Now similarly, what if you say, oh, sir, this is really so big, so the friction force could be maybe much bigger, so I keep the book like this and move. Here area is very less, area of contact. Here area of contact is so much. In these two cases, tell me which case will have less friction. This case or this case? Many of you will say, this has a very less area of contact, so this will have less friction. This has more area of contact here, and it will be more. Remember, it is independent of area of contact. Frictional force is independent of area of contact. Contact. So you keep like this or you keep like this, everything is same. It depends mainly on the weight of the body, mg, and how much it is going to give a reaction. So that's what it is written there. It does not depend on the size, area of surface. Second point, law number 2. The force of friction is tangential to the surface of contact and its direction is opposite to the direction in which the body would start moving. So when you give an external force like this, force of friction which direction will start, don't think it will start here, there and all. It will exactly will be opposite to the direction of the force which is being applied. It is opposing the external force straight away. So that's the way it is. So it is tangential to the surface of contact and its direction is opposite to the direction in which the body would start to moving. Third point, for the given surface, the limiting friction value is directly proportional to the normal reaction. The limiting frictional force is directly proportional to the normal reaction. What does it mean by that? So if you have a body, draw this diagram and keep. This diagram is important. You have a body here. Keep a block on top of a smooth surface. Now this will have a mg here and this will have a reaction. It is always, any body which is just kept on the top, it will have these two. You give an external force and whenever the external force is there, immediately the static friction force will be acting, and after once the body is slightly about to start moving, it will become limiting friction here. Now this limiting friction depends on what? The limiting frictional value is directly proportional to the normal reaction. What is normal reaction is actually equal to? It is equal to mg. Normal reaction is equal to mg only. We know this one, it is always equal to mg. But here the rule says, the law it says, limiting friction value depends upon the normal reaction. That means bigger the body, higher the weight, definitely frictional force will be bigger. So you can have a lighter body, then friction force will be less. Bigger body, friction force will be more. Now let us remove this proportionality value and put equal to, that is called mu s times of r. So this entire thing is called maybe the static friction here. So we can call it as, instead of limiting friction, you can call it as static friction also, the maximum static friction. Okay. So Fs, the maximum static friction, is directly proportional to the normal reaction. Capital R is normal reaction. And Fs is equal to mu times of R. What is mu? Mu s is called coefficient of friction. So let us try to see what is mu s itself. Mu s is equal to, bring this one down here, so it is static friction upon normal reaction. So what is this value? This will be newtons here, this also will be newtons here. Newton get cancelled out, so it is a dimensionless quantity. It doesn't have any unit. Okay, no unit for mu s. Mu s doesn't have any unit. Let us read this one. Now look at this one. Fs is directly proportional to capital R, normal reaction. Fs is equal to mu times of R. In this one, diagram is missing. Diagram I have already drawn. Please draw the diagram. This diagram I have already drawn. Please make sure this diagram is there. So where the constant of proportionality mu s is called coefficient of static friction or limiting friction. So the above formula holds only when Fs has its maximum limiting value. It is only for the maximum value when it is about to start moving. It is there. Okay. So we already seen this one. Mu s is equal to Fs upon R. I already have written that one and shown. And it says the coefficient of static friction or limiting friction is the ratio of the, what is this one? The coefficient of friction is the ratio of frictional force upon normal reaction. Limiting frictional force to the normal reaction. Okay. This is the first one. When there is a body is at rest and is about to start moving, that is called laws of limiting friction. Laws of limiting friction is the maximum of the static friction. Static friction is Fs and the maximum value is there. Now we go to the next value. What if the body is already moving now? When the body moves, what happens? So we come to the next part called the kinetic friction, the sliding friction. When the body is on the move, once motion starts, the frictional force acting between the surfaces decreases, so that a smaller force F is required to maintain the uniform motion. Only when the start is there, when you are about to push and start, then it will be tough. Once it starts, then it keeps moving. Have you seen a vehicle, maybe some car is there and it is not moving and everybody pushes the car? Once the first move is started, and then it is quite easy sometimes. And even for studying also, it is only starting is a problem. When you start and it will go on. So similarly, when the body is sliding over another body and the frictional force is there and the external force, the static friction is constantly increasing, at one point of time the body starts moving, then the frictional force, when the body is on the move, when the body is already on the move, the frictional force which comes into play is called kinetic friction, KFK. That's called kinetic friction. This body is already on the move. It is going towards this direction. When it is the frictional force which comes into play when it is constantly in the motion. Now look at this. The force acting between the two surfaces in relative motion is called, when the body is one above another is moving, it is relative motion is called kinetic or sliding frictional force, Fk, which is less than the limiting friction. And this Fk is less than the value of Fs. It is definitely less than this one. Okay. We know from daily experience that a lesser force is required to maintain a motion of a body than the force required to start the body from rest. We already have seen it on experiences. Now there are again 3 laws of this one. Please remember There will be slight difference between that one and this one, but it's quite similar. There will be very, very minor differences. So don't ignore saying that, okay, I have learned this one and I need not learn this. Please write this one also once again. The force of kinetic friction is independent of the area of contact. Already we've seen this one. Area of contact of that one and this one is independent. Now, one example is, have you seen a cycle wheel? In a cycle wheel, you have a brake shoes. Have you seen a brake shoe? When you apply brake, immediately this one, the rubber will come and touch the rim and will stop and the cycle will stop. What if you put a huge big rubber piece, then you will apply, when the wheel will stop fast? No, that is not. Don't mistake that big rubber padding brake shoe will stop the rim immediately. No. If you see, look at the big cycles, even the mountain bike and then the racing bikes are all very tiny, very, very small brake shoes are there when compared to the whole surface of this one. So it is independent of the area. It doesn't depend upon the area of contact. For this one and the big one, everything is area is the force will be same, right? The next one is the kinetic friction is almost constant for the given pair of the two surfaces. It is the value which will be contact of, it will be same. For example, it is the block is moving on the floor, then it is having a value. That value is always a constant and it acts opposite to the value. The force of kinetic friction is directly proportional to the velocity of the is directly proportional to the normal reaction present between the two surfaces. One thing is missing here is, I have not told, it is also, instead of area, it is also, you could have written as velocity between the two bodies. Suppose somebody will say, if I move very less in velocity, more friction will be there. When I move very fast, in a much more higher friction will be there. No. Velocity is independent of the frictional force. Less velocity, more velocity, if the two bodies are in contact with each other, nature of the substance and the normal reaction will only takes place. So it is there. Coefficient of kinetic friction is directly proportional to the normal reaction of this one. So Fk is directly proportional to R and Fk is equal to mu k times of R. What is mu k? Coefficient of kinetic friction. So what is mu k is equal to Fk upon R. So this is especially when the body is on the move. So you find a value here, mu k, and is equal to Fk upon R, force of kinetic friction upon normal reaction. The next one is, there's a very, very important graph here. Please draw this graph. It is between the external force. This is external force applied, and this is the frictional force. So first of all, when the body is on the rest, when the body is at the rest, so you are putting a force here. Suppose this is the force you are applying. You are applying only this much force, and the friction, kinetic friction also, that only will be there. Only this much will be there. So when external force is increasing, external force keeps on increasing, kinetic friction also, this frictional force also, the static friction also keeps on increasing. So it becomes a graph which is very much a linear graph. You will find it is directly proportional. It is keep on increasing till a point, a maximum value of the static friction. That is called a limiting friction. Static friction region is this much, and it is maximum, it becomes a limiting friction now. And then it goes for a bump down, and then the body starts moving here. External force is still increasing now. The body starts moving, and the frictional force which comes into play when the body is on the move, it is called the kinetic friction here. From here to here, it is called kinetic friction, kinetic region here. Please draw this diagram. Explain 2 points, 2 paragraphs you write. First one is from here to O to A, you please explain. When external force is increasing, frictional force also keeps on increasing and goes to the maximum value, and after the maximum value, that is called limiting friction, and then the body starts moving. When the body starts moving, the frictional force will be less than the limiting friction. So the force is given here as Fk, and the body starts moving over this one. The applied force is increasing, but the frictional force will not increase anymore. That is all. It is this constant here. You keep increasing, frictional force will not increase. So that's what it is given here. This graph is important. Please draw this graph in your notebook. The next one is angle of friction. What is an angle of friction here? So a quick representation here. Draw this diagram. Body is here. This is mg and this is normal reaction, and we see this is the frictional force will be when the body is on the move here. When the external force is here, this is the frictional force, kinetic friction I can say. Now this is the frictional force, kinetic friction force, this is the normal reaction. In between this one, maybe what I can do is I can draw a line like this. This is the frictional force. There could be a resultant could be taken here. This resultant, the resultant has an angle here, theta. What is the resultant? Resultant is between the frictional force and the normal reaction. And the resultant will have an angle between the normal reaction and the resultant. This angle is called angle of friction. So how do we define this one? Can we define this one? You need to write in lines. So the resultant between the frictional force and the normal reaction. Okay, the resultant has between the frictional force and the normal reaction has an angle between the resultant and the normal reaction is called angle of friction. This is the angle. Now please see this definition here. So please draw this diagram. This diagram is missing again here. Please draw this diagram. In the state of limiting friction, the angle which the resultant P, the angle in which the resultant, I can say resultant is P. Okay, so make this as a resultant P. The angle in which the resultant P makes with the normal reaction is called angle of friction. So, how angle of friction will be? Now write tan theta is going to be equal to, what is tan theta? Tan theta will be equal to this one. Here it is Fs upon, this is Fs upon R, opposite upon adjacent side. So we know already this tan theta, Fs upon R we already know. What is Fs upon R? Fs upon R is already equal to mu. So it is going to be equal to mu s. So theta is going to be equal to tan inverse of mu s. So you find here theta s is equal to Fs upon R, theta is equal to mu s. Okay, because what is mu? Coefficient of friction, right? So the coefficient of friction is equal to the tangent angle of friction. What is theta? Theta is the angle of friction. So remember this one with the diagram, and with this one you should know, right? The last topic for today, it is angle of repose. Angle of repose. So draw this diagram. Draw this diagram. There is a block here. So, and in this block, the block is about to slide. So it is on the verge of having a downward motion here. So in that motion, let me try to illustrate this one in this way. Okay, I have a two plank one. One plank is down, another plank is there, and I put a box here. Now the top one, I lift this plank up. So what happens? So it will become like this. I'm lifting this one. This plank is being lifted. And because there is an angle here. And I lift more. I lift it more. So when I lift more, at one particular time, at one particular moment, this block will just start sliding down. The angle of the inclined plane, when the block just on the verge of sliding down, this angle is called angle of repose. Okay, now let's read this one. It will be written here as, okay, the definition wise you have to see where it is there. Fine, it is not clearly given in the right position. Okay, I have defined you what is the angle of repose. Now we will start giving this one. We know this one is mg and this one is going to be equal to r, and what is this value here? This is theta, this is mg cos theta, and this one is going to be mg sin theta, and the frictional force will be acting this direction. Okay, so when the body is just on the verge of starting, what happens? R is equal to this one, so you can say R will be equal to mg sin theta, and it is not started moving, it is just on the start of moving. So mg sin theta will be equal to frictional force, you can say, because it is just on the start of moving, sliding down. So frictional force is going to be equal to mg, it's all static, mg, sorry, this is going to be cos theta, this is cos theta because r is opposite to cos theta here, this is sin theta. Alright, so this is equation number 2, this is equation number 1, divided 2 by 1, what happens? Mg sin theta divided by mg cos theta is equal to fs upon r. This will get cancelled out, it will become tan theta. Tan theta is equal to fs upon r. What is fs upon r? We already know this value. It is a constant. Fs upon r is always a constant. So tan theta is equal to mu s, because mu s is fs upon r, right? So that's what is given here. So you have two values, f is equal to mg sin theta, and then r is equal to this one, and divide this one, you will get mu s is equal to, that's value you will get. Okay, the coefficient of static friction is equal to tan theta of a theta value. This theta is called angle of repose. Okay, when the body is just on the verge of sliding down. You can just read this one and make this short part of it, and please write down angle of repose is the angle in which the inclined plane makes with the horizontal when the body is on the verge of moving down. Then that is called angle of repose. Please write down. And the next part of it is rolling friction. You have to read this one yourself. Okay, the rolling friction. What is rolling friction? There are three frictions. Is there static friction, that is called, another was limiting friction, and then you have the kinetic friction. The last part is rolling friction. Type of kinetic friction has two types. One is sliding friction and rolling friction. So sliding friction already know, one slides over another. What is rolling friction? So rolling friction is when a wheel rolls over the another one. So when this one, it is just rotating, moving like this and keeps moving down with a velocity, then that is called rolling friction. So there is a radius is involved here. Okay. Now why this one, what happened to the rolling friction is, rolling friction is quite a simple one, because the body, when it moves, it just depresses down a bit. And if there is no friction, this will start slipping. So if a tire is there, floor is there, it will start slipping if there is no friction. So there is a friction, so friction force will be little helpful to just hold it together. This tip to tip is hold it together, and after some time this will be holding together, so it will keep on moving. So that's the way the body moves, rotates, and keeps moving ahead. So this friction which comes into play when the body is rolling on the surface. But remember, there are two friction. The one is, it will allow, the friction force will allow not to slip, but at the same time, don't think it is advantageous. So velocity in this direction and friction also in the same direction, so the body will go faster. No, the body will anyhow retard. You roll a wheel on a smooth surface, after some time it will stop. Why it is stopping? If friction force is little helping it not to slip and allowing it to move forward, still it will stop, because the cohesive force means the rubber molecules and the surface molecule will be quite in touch with each other, and it will not allow it to move forward. The cohesive force will try to attract, not allowing to move. That's number one. And next one is, there is a depression it makes, and it has to overcome the depression and go to the next side. So because of that, there are two reasons. One is called cohesive force, and the depression has to be overcome. So there is a rolling friction will be in place. The rolling friction is because of the depression which takes place, and the cohesive force which between the two surfaces has to be overcome. So it goes that, however, rolling friction is very, very less than static friction. Static friction is much, much higher. Suppose the same wheel, try to drag it like this, then that will be static friction, because it's sliding with over another. Rolling friction will be very, very less. So here we can see here, rolling friction comes into play when a body such as a wheel or disc or cylinder rolls over the other surface. In common experience, it is much less effort is needed to roll a drum or a coal tar or whatever it is. The reason of the rolling friction being much less, that is, only a very small portion of the moving wheel is in contact. A very, very tiny phase is only, it is in contact. So that's one of the point. And with the ground at any instant. And this portion is momentarily at rest. It is not sliding, since no work is done against the friction. So rolling friction is directly proportional to the normal reaction. So here it is, the mg acts here, and then normal reaction. So coefficient of rolling friction is directly proportional to the normal reaction, right? And also the second point is, it is inversely proportional to the radius of the wheel. So rolling friction is inversely proportional to the radius of the wheel. So how big is the wheel it is? So the rolling friction is proportional to capital R upon small r. So rolling friction is equal to mu r, capital R upon small r. So mu r into capital R upon small r is there. So which is the most less frictional force? So this is mu r is really less, and then it is less than the kinetic friction, and it is less than the static friction. Static friction is the maximum when you compare all the three things: rolling friction, kinetic friction, and static friction. So you find all the three, it is having kind of a analysis here, right? Alright, with this I close. Rolling friction is also over, and the rolling friction, some of the part is given here. Please read this one, why it is that it is moving. I already told there are some of the reasons which is there. It is getting in contact with each other and all the things. So please read this one about rolling friction, the reasons. So with this we close. Please read this one, and it is all the introduction of the friction thing. We'll later on move to the next part in the next lesson. Thank you so much.